All right. Hello, good morning, everyone. Today, we're going to be talking about dealing with a massive onset of data ingestion. I'm Ryan Levick. I'm a cloud developer advocate at Microsoft. You can find me on Twitter at Ryan_Levick. And here at the event as well, if you want to come and chat about what we talked about today or about anything, then come find me and I'll tell you where I'm going to be available later on in the talk. So the name of the talk is Dealing with a Massive Onset of Data Ingestion. If you're like me, when you first heard the name of the talk, you might have been like, what's that all mean? Well, at the end of the talk today, you're going to know exactly what that means. So first, we're going to talk about why we need to even care about data or big data and data ingestion. And hopefully you have some kind of intuition around that. If you've ever looked at or had to deal with a massive amount of data, it's coming in faster than you can really process it. And that's what we're going to be talking about today, is how we can deal with that, how we can make meaningful business decisions, meaningful action with our data, and do it in real time. So to begin with, we're going to talk about two new things that make this different than if you would have seen this talk or a talk similar to this 5, maybe even 3 years ago. The first one is IoT. So we have now the Internet of Things, a massive amount of internet-connected devices that exist out in the environment, and they are producing data at a massive scale. And these can be anything from the example today we're going to be using, which is cash registers that are producing data when people purchase something at a store, or it could be many other things. We'll look at a ton of examples. And this didn't really exist even a few years ago. And so now we have a massive amount of data coming in from these IoT devices. And the second thing is we're able to deal with that data in real time, where beforehand we had to kind of aggregate our data together and then batch process it after the fact, maybe a day later, a week later, a year later, or several years later. And now we can make and go through our data in real time and make decisions based on that data in real time. So what are we going to specifically learn about today? Well, the first one is we're going to learn more about these IoT and real-time processing opportunities, what that means for our businesses. And the second thing is the technology that's going to enable us to take advantage of these opportunities. So we're going to be looking at specific pieces of technology that happen to be running on the Azure cloud, but are also open source technologies. And we'll be able to take a look at these technologies and see how they enable us to take advantage of the opportunities that we've seen. So more specifically, in terms of agenda, the first thing we're going to be doing is talking about a company called Tailwind Traders. And this is a company you'll be hearing about throughout the day. We'll be talking about how they're producing data, how they're then consuming that data, and then how are they processing that data. And we'll wrap it all up with a demo at the end where we actually go through and live on stage, knock on wood, we're going to go through and we're going to see Tailwind Traders data being produced right now as I'm standing here, and we're going to process it in real time. So to kind of take a step back and look at the journey that the data is going to take, and thus the journey that we are going to be taking in this talk, we're first going to produce data. We're then going to consume that data somehow. Then we're going to process the data. And finally, we're going to react to that data, again, in real time. All right, is everybody clear on that? Cool. So the first thing we need to talk about is Tailwind Traders, which is a company, a retail company that has many locations around the world. And they're producing data from many IoT devices, let's say cash registers or some device like that. And they have data also from other sources as well, legacy systems and things of the like. And they're going to be producing that data, and they need to consume the data, process the data, and then go ahead and react to that data so that they can have an advantage over their competitors. So what does Tailwind Traders actually really care about when it comes to data ingestion or data processing? They care about it being in real time so that they can do the ingestion in real time and thus can analyze the data in real time. They want the ability to notify, and they want the ability to notify several different parts of their business, different sections of their company about what's happening. And they want the ability to automate reactions to whatever is happening. so that they don't just inform people, hey, we're having a massive sale of screwdrivers this week, but actually, well, can we go ahead and order those screwdrivers automatically without anybody ever having to be involved in that process? And they want it to be consumable everywhere inside of the company. So let's look at some technical requirements that we have here. This is where we're really going to be diving in. What does this mean on a technical level? So if we go ahead and expand these out and take a look at what it means to produce this data, we want the ability to have many devices that are producing it. We want them to be offline capable, meaning that they don't always have to be connected to the internet. It would be a real shame if the internet inside of one of our store locations went down, and that means that we can no longer collect data from that store. And we want them to be manageable and easily manageable so that we don't have to send out a ton of technicians to every single store. We can centrally manage those devices. On the consume side, we want it to be elastic, meaning we want it to be able to grow with our demand. So as we're using more and more data, as we're producing more and more data, we are able to then grow our data processing cluster to meet that demand of the data. We want it to be in real time, and really real time counts for all of these things. We always want this to be as close to when it's happening as possible. And we want to be able to support many sources. So we don't want to just get stuck on one thing. We want to be able to aggregate data from many different places. And then what we want to be able to do is, again, in real time, we want to process the data. We want it to be parallel. So we want to be able to do many different things at the same time. And we want to be connectable. So we want it to be able to connect to many different sources and process from many different places. And then lastly, on the React side, we want to be able to multiplex our data. So if we have many different systems in place to be able to react to certain events, like let's say we have an inventory system that we can order for, we have an email system that will email out when certain things happen and stuff like that. We don't want to have to just pick one of them. We want to be able to multiplex out. And we want it to function in a multi-system environment so that we're not just kind of vendor locked in. So let's focus on producing data then. And we're going to be talking about IoT devices. And again, IoT standing for Internet of Things. So these are small devices that are connected to the internet. And in the center of that is the intelligent cloud. So that's what we'll be focusing on today, how we can take advantage of that. But on the outer edge of that is the intelligent edge, meaning the devices themselves have a certain sense of intelligence to them. They can make decisions on their own, and they can be manageable from that intelligent cloud at the center. So let's look at some examples of nowadays, how are people producing data? So in the manufacturing space, for instance, we have predictive maintenance. So you can think about if you're on an assembly line, the assembly line machines can notify a central system that they need to be maintained somehow. So you don't have to have people going around and checking devices every day. They can just inform a central location. Inside of healthcare, you can have patient care anywhere. So instead of having to have a doctor come and check on you every single day, instead you could perhaps wear a wearable device or something like that sends data trusted over the network to a central location where, of course, only your doctor will be able to see that data. And you can get your care from your home instead of having to either visit a hospital or have the doctor come to you. For instance, in transportation, we have traffic monitoring to be able to tell, okay, are we experiencing higher traffic than normal? Do we need to maybe change how lanes are set up or things like that? And I think this will become more and more important as we go forward. And a big one, of course, is their energy. So can we use less energy if we don't need to use it? We're probably wasting a ton of energy, but if we could have devices that say, hey, I'm not actually being used right now, then we can just automate it and turn them off when they're not being used. In the area of agriculture, we have things like water scheduling to be able to tell, okay, this IoT device inside of our fields is measuring how much water is in the soil. It detects that it doesn't have enough water in the soil, so it goes ahead and schedules more watering. Again, smart cities, for infrastructure monitoring, this is related also to transportation as well, but to be able to make smarter decisions about how we live in cities based on data that comes from devices spread around the city. And lastly, the example we'll be focusing on today is retail. So really what this comes down to is being able to provide better value for your customers. And that means, for instance, not running out of things because you know if you're having high demand for a certain item, then you can go ahead and purchase that ahead of time so that you never run out and your customers are always able to purchase what they want. And that's the example we'll be focusing on today with Tailwind Traders. So to kind of make it a little bit more concrete, here's the technology that we're looking at. Here's an IoT board that you can purchase, for instance, that comes kind of connected with Azure IoT. And what it runs on it are some container images that ensure uptime. So it has a listener on board that basically makes sure that if you have some kind of issue inside of your container and you have, let's say, an exception that gets thrown, something goes wrong, it can go ahead and restart the device for you. It's also offline capable, so it has a local buffer inside of it that basically, as you're producing data, it puts it into that buffer and then tries to flush it out to the network. If you're offline and it can't flush it out to the network, then it will just sit in the buffer and wait until it gets network. So that eventually, when it comes online, then it can flush that buffer out and you haven't lost any data then. And really cool thing is it's centrally manageable. So you're able to, from a centralized location, look at your devices, tell how many are running, if any are offline, what is happening to them. And you don't have to actually go out into the field and actually look at the devices in order to tell how they're doing. So I want to take a second to pause here on a docs alert. We'll have a few of these during the presentation. And this one is specifically on IoT hubs, which are the central place for managing your IoT devices inside of the cloud. So if you want to learn more about how to do device management and things like that, then I definitely recommend going ahead and looking at these docs. I'll pause for one more second if anybody is taking a picture by any chance. So the next thing we have is consuming data. We've produced our data from our IoT devices. How can we go ahead and consume data? And so there's some hard questions we need to ask here. For instance, why do we even need a centralized data ingestion system? Why do we need something sitting in the middle that ingests all of our data? And hopefully the answer can be a little bit intuitive, right? If we have one centralized location that we push all of our data into, then we can multiplex that data out anywhere else into our system. That means that we don't have to rely between producer and consumer, that they know how to talk to each other. We can basically push from a producer up to our centralized store, and then it says, well, whoever wants to listen to it can go ahead and listen to it, but I don't have to care about what those things are. There's no direct connection there. And this allows us to do a lot of optimizations and allows us to basically be very flexible about when we add new producers, we don't have to worry about, will our consumers be able to understand this? And when we add new consumers, we don't have to understand if our producers can understand the connection either. It all goes through one location. Now you might be asking a question about, what about a simple queue? So why can't I just push something onto a queue, and then at the other end, there's another consumer of that data that pops the data off the queue, and we're done. And there's no need for some fancy infrastructure here. Well, a simple queue is not quite good enough here. The reason being is you want to have multiple consumers of your data. You don't want to just pop off one piece of data from a queue and then say, well, if you also wanted to look at this piece of data, you're out of luck. I'm sorry. You want to be able to have multiple consumers looking at that data and to look at it over a window of time as well. So once you pop something off of a queue, for instance, it's gone from that queue and you're not going to be able to look at it anymore. But if you have something that has a windowing mechanism where you can look at data over a kind of a window of time, what that allows you to do is look at the data over that time and make decisions based on, okay, this changed from this morning or last evening, instead of what is this one piece of data telling me? And this is really where Azure Event Hubs come in. This is what Azure Event Hubs provides. It provides a place for you to locally have, or out in the cloud, have a centralized place for consuming your data. And what it comes with is things like auto-scaling. So as you grow, as your business grows, it scales with you. You don't have to do that yourself. And it has adjustable data retention periods. So this is what we were just talking about, of having a window of time that you can look at your data. Instead of just popping pieces of data off the queue one at a time, you can look at it over a period of time, whether that be a few hours or a day or even a week. It can persist data to cold storage. So if you do need to look at this data later on in time, let's say years later, or decades later, that's fine. It can be pushed off to a persistent data store for later consumption. And of course, it can integrate with other Azure services. So if you're already using Azure and you have other systems inside of Azure that need to be able to work with this data ingestion system, then that's no problem. And if you're already using Apache Kafka and know about Apache Kafka, then this should feel kind of familiar to you. And of course, Azure Event Hubs has protocol compatibility with Apache Kafka. So if you have systems that know about Apache Kafka, you can easily switch them over to Azure Event Hubs instead. So we talked about IoT hubs, which was where we are able to manage our IoT devices, and we talked about event hubs, which are these kind of scalable, centralized data ingestion points. And the nice thing is that IoT hubs are event hubs. So basically an IoT hub is just an event hub with some IoT device management on top of it. So if you go ahead and provisions out an IoT hub, then it's very easy to take advantage of the event hub stuff that we're talking about, because you have, for instance, a built-in Event Hub compatible endpoint on your IoT hub that can do all the things. And anything that you learn about event hubs will therefore translate to if you're dealing with IoT specifically. And of course, on top, your IoT hubs have that additional IoT device management. And one really cool thing here is that the communication between your IoT hub and your devices out in the field are bidirectional, so that if you go ahead and want to talk to your device can talk right back and report to you. So let's take a look at what this kind of means in a picture way. On the right-hand side of the screen, you can see we have where we're going to go ahead and present our data or kind of consume our data in some way, whether that be Power BI or some kind of analytics system. And then on the left-hand side, you have the producers of that data. And how do they get from one to the other? So you have here kind of front ends that collect that data. Then you ingest that data into Event Hub. So this is our one central location. Everything is coming into it. And then you can split that data out to multiple places. So whether that be some kind of stream processing, which we're going to look at later on in this talk, or whether it's some, an Azure function or something like that that can take advantage of that. And of course, you can move that data on into cold storage for later use if you want to. And this is how your data gets from your producers onto your consumers. So if this sounded a bit interesting to you, then I would definitely recommend checking out the docs online about Azure Event Hubs. And again, I'll have this link at the end of the talk for you to take a look at. You can learn all about how to provision an Event Hub and go ahead and take advantage of this real-time processing. And we'll take a look at that in more detail later on in the talk as well. So now that we've kind of gotten the data into our system, we have a hold of it, how do we actually process that data? This is where we need to talk about the difference between batch and real-time processing that we kind of alluded to before. And you're probably familiar with batch processing because it's pretty well understood with the ETL type of tooling that you have. You have this rich tooling that comes with a long tradition, long history. But the downside is sometimes it can be slow and cumbersome. But real-time processing, on the other hand, allows you to handle individual messages, all down to the actual individual message that, for instance, an IoT device is sending up to your central system. And because of that, you get faster performance. So you don't have to wait for your data to collect over a period of time. You can process it as it comes in. And it's important to understand the time value of data. So as data comes in, it's very, very valuable right at the beginning. And we can think of, for example, a fire alarm, right? It's very important to know about a fire alarm right as it's happening, right? And as that time goes on, it becomes less and less valuable, right? It doesn't really help a ton to know 3 hours ago a fire alarm went off here, right? You probably should be out of the building and worrying about other things. But as time goes on, that data becomes more and more valuable. So we can start aggregating things together over time and saying, okay, in the past year, we had this many fire alarms go off and things like that. And we can start looking at it over a long period of time. So batch processing doesn't need to go away, Batch processing is here to stay, but real-time processing has its place. It has its place at the beginning of this kind of curve of value. And so we can look at some kind of scenarios that real-time processing is especially useful for. So for instance, fraud detection is a big one. You want, if you have a credit card, for instance, and your credit card company should see some kind of suspicious spending that might be happening on that credit card, you want them to notify you as quickly as possible about that, and not, well, we saw over the past 5 years you've had some very suspicious data happening on your credit card bill. You should probably look into that. Well, it's probably too late by that time, right? And you have things like patient monitoring in real time, IT infrastructure and network monitoring to make sure that nothing fishy is happening on your internal network. And of course, real-time demand and inventory management as well. And again, we're going to be looking at that as a specific demonstration. So then there's kind of two pieces of technology that come into play in this real-time data processing that will build on what we've already learned about IoT hubs and event hubs, and that's Databricks and Apache Spark. And we'll look at both of these now. Apache Spark is a unified analytics engine for large-scale data processing. This is from their website. And really what it means in layman terms is that it allows you in real time to take the data that you've ingested and go ahead and do something with it, whether that is aggregated over some period of time to do kind of, if you're familiar with SQL, for instance, think of all the things that you can do with SQL. You can do these things inside of Apache Spark as your data kind of rolls in. And Databricks is just basically Apache Spark with some more features on top, is the way you can think of it. Builds on top of Spark, adds highly reliable and performant data pipelines and productive data science at scale, again, from their website. And what that means is basically it's a Apache Spark without as much headache. And if you really don't like having headache at all, then you can have Azure Databricks, which takes advantage of Apache Spark and Databricks and puts it on Azure. So that if you want to set up some kind of real-time processing pipeline, you don't have to go ahead and do it manually yourself. You can just click a button and it will be set up for you. And that comes with a whole bunch of things like auto-scaling free out of the box. And of course, you get native integration with Azure services as well. And of course, enterprise-grade Azure security. So you can have all of things like AAD groups and namespaces so that you know that your data is secure. So let's take a look at some features of Azure Databricks. Again, it's a managed service, and that cannot be stressed enough. It's really nice to have a service that you don't have to worry about supporting yourself, and that comes with reliability of it being up, and with security and things like that. You don't have to worry about that yourself. You have auto cluster shutdown and scaling. So for instance, we have a whole cluster of machines that are powering our Databricks instance. And if we're not using it, well, we want it to just shut down for us so that we're not spending extra money. And if you're managing it yourself, well, then you have to take care of that. And I know I've been in situations where we've forgotten at times to shut things down, and you end up spending money for absolutely no reason. And the opposite is true as well. You want to be able to scale as you go along. So as your business is growing and you're using Databricks more and more often, you want us to be able to scale more and more with you. And you don't have to take care of that yourself. You just want it to happen. One cool thing that we're going to be looking at inside of our demo is notebooks, which allow you to deal with your data in real time inside of a notebook and write code to deal with that data and run it from inside of your browser. So you don't have to have a huge kind of system set up to go ahead and run code based on this. It's all there right in your browser. And we'll see what that looks like actually a little bit later on, not too long from now. And this all can be version control. So if you have something inside of Git, for instance, you can put it in there. And if you make some changes and don't like what the changes you made, well, you can just easily roll those back. Of course, you can take advantage of Apache Spark and its open ecosystem. Apache Spark is open source. So if you want, and there's a ton of resources out there for learning about Apache Spark. So if you want to go ahead and take advantage of those resources, take advantage of tooling around Apache Spark that's been created without Databricks or without Azure Databricks in mind, then that's totally fine. And it's completely open for you to do that. And like I said before, you get integration with Azure products, kind of out of the box and first class. And so another way to think about this is that you have, on your left-hand side, again, you have your producers of your data. On the right-hand side, you have consumers of your data. In the middle, you have various pieces of your business that care about data. So you have your data scientists, your data engineers, you have all these people that need to work with data in some capacity. And what kind of unifies them together is their ability to work with that data through Azure Databricks. And you can multiplex that data so that not one part of your company needs to or even wants to have a monopoly on that data. All right, so again, a docs alert. If you want to learn about Azure Databricks, then you can go ahead and take a look at the documentation here. Once again, we're going to have this link at the end of the presentation as well, so don't worry about missing it here, but it's really also, again, an opportunity for you to go through and actually deal with data that's an example of data and see how the data gets processed in real time right there from your browser screen, just like we're going to do in just a second. So let's go back to Tailwind Traders and think about the example that we're going to be dealing with today. At the top here, we have our cash registers, our IoT devices. They're out in the field, they're in our stores, and they're producing data that's being pushed up into to an event hub. And we have other systems out there that perhaps they're legacy systems or even new systems that just happen to not be IoT systems that are coming in and being pushed into this event hub as well. So that's all great. It's all going into a centralized place. And what we can do with that is push that data off to many different places. We can push it off into doing cold storage, for instance. So if we want to push it to Cosmos DB for a long-term geo-replicated storage, then that's easy to do. And if we want to then push it off into our Azure Databricks instance to be able to do this processing in real time, then we can do that as well. So the data can go to multiple places, all because it's going to one centralized place and then being pushed out from there. So that's the example we're going to be working with. And next, we're going to have a demo of what that actually looks like. All right, so and here we're inside of the Azure portal. We have an IoT hub. And again, I want to reiterate the fact that IoT hubs are event hubs as well. So there's an event hub endpoint that you can just push the data right into. You can look at this here and this built-in endpoints that you have here. We can take a look at how our event hub right now, or our IoT hub is running right now. And you can see that we have messages coming in. And we can look at our IoT devices down here. If we look at device management, then we see we have several devices here. And if we click into one, we can see how it's configured and things like that. One interesting thing to look at here is one container that's running on this IoT device that's running somewhere in our store is the very legitimate IoT Edge bogus data generator that's producing lots of real bogus data for us. And this is what's going to be powering our demo today. So of course, we don't have people actually purchasing from Tailwind Traders today, unfortunately, but we're still going to be looking at data that's coming from this. And of course, you could change this container out with something more legitimate, perhaps like the system that's actually running on your cash register, that's actually going through and producing data about purchases that are being made. All right, so we have that. I'm going to go ahead and switch over here to our Databricks instance that we have here. And it says it's connecting. I'm going to go ahead and refresh here. And again, this Databricks instance is going to be running in the cloud. And it's going to be taking in data from our Event Hub, and we're going to be able to process it. And the first thing that we need to go ahead and do is think about securing things down and actually authenticating with the service here. And the way that we can do that is by using a Databricks CLI tool and creating things like scopes and secrets. And these are strings that we don't want people to necessarily be seeing, like the people in the audience today, or even me, for a fact. I shouldn't be knowing about this. And so we can use the code down here to go ahead and create these secrets for us. And I just want to stress two facts here. First of all, the code that you're seeing here is Scala. So if you're not familiar with Scala, don't worry too much. There's other languages that can be used in here. We can use SQL, for instance. We can use R. There are other languages that we can use. So we're just going to use Scala for today. And it should be fairly readable. When I hit this play button here, this code that you see written in this rectangle right here will actually be run. So sometimes it's not obvious that I'm going to be running this code, but I promise you this code will be run. So if we go over here and hit run cell, it's being sent up to our cluster that's running inside of an Azure data center somewhere, and it's going to be executed. And the first one that gets executed sometimes takes a little bit of time. It needs to get things a little bit warmed up. So it's getting an execution context, and it's going to head and run this. And then we should see our secrets printed out to the screen. So let's wait for that. We can see down in the next screen below, we have an EventHub connection here that we're going to be setting up. And we're going to set up our connection using the secrets that we've established in the first square above. So you can see here when we scroll back up, our connection strings are printed out with redacted here because we've told the system, hey, this is a secret. Don't show this to anybody. So you don't have to worry about seeing secrets when you're going through things here. It will all be redacted out. Like I said, we've established a connection here to our Event Hub, and we're going to be reading the stream of data from an Event Hub in an Event Hub form. So if we go ahead and run this real quick, we're going to print out the schema that we're going to be getting from our Event Hub. And you can see the schema here. We have things like publisher, for instance, partition key, and queued time. So it's a lot of metadata here, right? We have a kind of a loosely typed map of properties that we can put in. For us, a lot of this is not going to be interesting. The interesting part is going to be the body. And this is the payload that's coming from our IoT devices. And we can check to make sure that our IoT devices are actually streaming by checking this is streaming property here. So if we run again, we should see true, and we do. Okay, so we've got streaming data come in, that's good. And what we want to go ahead and do is create that stream, and right here where we see cast body as string, we're going to take that binary data that we have, that we saw before, and we're going to cast it as a string and call it message content here. So let's go ahead and do that. And that will go ahead and run. And the next thing that we can do is take those messages that are just strings, and we can go ahead and print them out to our console. And we've already said before, we've limited our max events per trigger to 5, so we're not going to be inundated with data here. And for this, it's not a huge deal, but if you're dealing with actual data, you probably want to set this to make sure that you're not getting overloaded with data as it's coming in from real devices. We're going to print it out to the data, and we're going to set truncate to false so that we don't truncate anything. Otherwise, by default, things can kind of get chopped off, and we won't see everything that we want. And if we go ahead and run this here, we'll go ahead and see that being printed out. So you can see here it's being printed out. The first batch is always empty. But if we scroll down, we can see our actual data here. And you can see that it's coming in a JSON format here, and it has things in it like order number and purchase ID, store name, the SKU number, things like that, and actual name of the item being purchased. So that's all great. I'm going to go ahead and scroll up real quick and cancel it. And then I'm going to run the next slide because it takes a little bit of time for it to go ahead and run. So what we want to be able to do is take the string of data that's coming in, this JSON data, and actually make sense of it using real types, right? We don't want to always have to be dealing with strings bouncing around and doing string processing. So we want to go ahead and say, okay, this is JSON and it has this format. And you can see that we have this IoT schema here that we've defined. So we have a field called order number, and that's an integer. And we have a purchase ID, and that's a string type. And we have an items, which is an array that has a SKU, a name, and a price that are a string, and an integer, respectively. So what we're going to do is basically say, as these messages come in, take the JSON that's inside of message content and parse it using this schema and call it data. And then we're just going to explode out all of that data. And if we print the schema here, you can see it again in this form down below. Again, I'll run this. And if we take that data as it comes in and we can display it out to our console, then we can see it being shown in a really interesting form that allows us to see our data as it's coming in. So you can see here, here's our actual data coming in, and I want to stress again, like this is coming in from an IoT device. Sure, that IoT device is producing that data in a bogus way, but if you just imagine that it's actually people purchasing from that IoT device, this is coming in real time, and we are seeing it in real time. One interesting thing about this is that the data is sort of bunched together, where if a customer bought multiple items, we see over here we have the items array here, and we can bump that out here. We can see that this particular customer bought 2 items, for instance, here. And this is really nice because it allows us to send the minimal amount of data that we have to send from our IoT device so that we don't have to send an individual package per customer every time that they buy something. We can just say, this person bought 4 items, here they are. But when we're working with the data, when we actually want to process it, that's not always the best thing for us to work with. So what we want to do is go ahead and flatten that data out so that each purchase, even if it's by the same customer, is represented by one row of our data, basically. And so we can use these interesting functions called explode that explode our data out and say, for every item inside of our items collection here, go ahead and take the order number, the purchase ID, and the store name, and just go ahead and explode it all out together so that everything is on one line. And again, I'll go ahead and run this. And what we'll be able to see when we run this is that everything will go from being, okay, this customer purchased 4 items, and here they are, to these are the items that were purchased. And you can see, again, this is coming in real time, and we can see the items coming in here. And one nice thing here is we can see it, in different representations. So we can go ahead and see how many of a particular SKU are being purchased here. So for instance, it looks like TT2099 is being purchased quite a lot here. And of course, we also get a name coming in with that as well, so we can take a look and see what that SKU number actually is. One also nice thing that's not really related to our data and our demo today is that if we go ahead and run this cell here, we can display pretty rich data types here. So we have just an image coming from the internet. And so if your data includes things like images or rich media and things like that, then you can actually display it in this workbook as well. So that's really great. So one thing that's really nice is that we can go ahead and perform groupings and aggregations and orderings. So for instance, in this particular piece of code, what we want to do is take the name and the SKU, and we want to count them together. So we're grouping things by name and SKU, and we're kind of aliasing that as actual number of purchases. So we're going to go ahead and display out our actual number of purchases here. And we can format that to the console to be read out of the console in a more textual format as well. But for this one, we're going to use the display function, which provides us really nice visualizations. I'll take the opportunity here to shout out to my next talk again. If you're interested in data visualizations, then make sure to stick around and we'll talk about how to visualize data as well. So this is going to take a little bit of time to go ahead and run as we aggregate our data together. And in the meantime, I'm going to go ahead and run this as well. So this particular line here in the next one is going to aggregate by store name instead. So before we're saying what items are being purchased and what quantities, and now we're going to be saying what does store revenue look like. So we take the prices of items purchased at particular stores, and then we group them together to see what those look like. So our counts are starting to come in, and we can see things. For instance, here, our Phillips head screwdriver is doing pretty well here. And again, we can visualize those in different ways. I think this pie chart is kind of fun here. So we can see that 38% of our purchases here have been Phillips head screwdrivers. And this, again, is coming in real time. So this is 30% of the data that are purchases that have happened since I started this demo. And don't fret, of course, all of this data is also going off into cold storage so that if we're not dealing with it particularly right here, we can deal with it in cold storage and do kind of the batch processing that we're already familiar with. And this here is showing, again, we should see we've only had purchases from our website right now. There are actual retail stores as well. There it is, okay, Redmond Center. So we can see again, and again, I like the pie chart here, it's fun. So we can see 55% of our sales have been from the website where these things are being purchased as opposed to from our actual physical retail stores. All right, let me run the next cell here. So one thing that we might want to be able to do is make decisions based on our data. So how can we actually measure the demand for our data? What does that actually look like? And what we can go ahead and do here is set up a connection to Cosmos DB. So this, again, is happening inside of our Databricks instance. We're setting a connection to our Cosmos DB instance, and we're going to have a table that basically specifies how much high demand for a certain item is. So you see here we have Phillips head screwdrivers. If we purchase 14 of those, we're in a high demand time frame. And we'll look at what those time frames actually are in just a second. And also extension cords. If we have 14 extension cords in our time frame, then we're in a period of high demand. So we can go ahead and set all this up and have this table inside of Cosmos DB, and we've printed it out to the screen here to take a look at it. So we can see what, for a specific item, what does high demand actually look like. So I'll scroll down here and run this cell. And this is where we're defining our actual time intervals. Obviously, 14 Phillips head screwdrivers is not a ton of screwdrivers over a year. But perhaps, as we have here, over a 2-minute time period, that might be what we define as high demand. And so what we're setting up here is a sliding window that we care about. We care about 2-minute intervals that shift over 1 minute at a time. So we're looking just at those 2-minute intervals and making decisions on the data in those 2-minute intervals. So once data comes in that's older than 2 minutes old or whatever, we're not going to care about it anymore. But again, it's going to cold storage, so we're not losing the data, we're just not dealing with it right now. So next we come down here, and we're going to go ahead and define a UDF, or user-defined function. And what this allows us to do is define a little bit of business logic on our own. And what we're going to say is that if we have actual purchases that are greater than the expected purchases that we have inside of our Cosmos DB, we're going to return the string high demand. And otherwise, we're going to return normal demand. And you can imagine making this much more complicated than our logic here, but it makes it quite easy here. And so we're going to take our windows, we're going to aggregate some things together, and basically be able to run our user-defined function and create a new column called demand level. And what this will allow us to do is see the actual demand level for different items as they come in. And so this is going to go ahead and run, and it takes a little bit of time to run, so we'll come back to it in just 1 second. And once we see that we have high demand for certain items, we want to be able to react to those things. So what we're going to do is create functions that inside of our Scala code here that will ultimately call an Azure function running somewhere else in our data center. And it's going to go ahead and react to high demand things. So when we get high demand, we'll call this Azure function, and this Azure function has internal logic inside of it that knows how to place orders with our ordering system. So when we have more screwdrivers than we were expecting in our 2-minute window, we will call this Azure function, and the Azure function will go ahead and order more screwdrivers for us. Let's see if this is running yet. It's still running. Come back. So we have these functions, and again, these are just simple HTTP functions here. And then we have something called a restocked transactions table, which is basically showing when something has been restocked. And this exists inside of Cosmos DB. So we have here a whole set of code here, and I'm not going to go through it all. It's quite a lot of code here, but again, to show you that you can write some serious code here. You can also import custom jar files. So if you wrote it somewhere else and you just want to import it and you don't want to write all this code inside of a notebook, that's also fine too. So we've defined these classes called restock transaction and restock transaction managers, which are connecting to our Cosmos DB instance and are going to make sure that they know when something has been restocked, reordered, and things like that. So let me scroll back up here. So we can see our data is coming in. And it's coming in quite slowly here, but it's gonna, as time comes along, you can see the windows that we're starting in right here. So these are the 2-minute windows that we're in. We can see that so far we've had 3 paint rollers purchased, and our expected maximum purchases that are coming in 17. So if we wait a little while, we'll see that we're gonna have some high demand here, just because we've set it up that way. And what will happen, because of our code down here below, is we'll pass high demand, we'll see that it's high demand, we'll automatically call our Azure function, and then we'll be able to restock our collection of our paint rollers and screwdrivers and things of the like. So if we can go ahead and take a look at our restock transactions here, take a look at what that looks like here. So you can see we already have, for instance, Phillips head screwdriver, where we've gone ahead and completed our transaction here. We can manually complete things down here with complete restock transaction. So if I go ahead, this one is in progress, for instance. If I just copy that, scroll back down, and run it, then we'll go ahead and complete it, and we'll run it later, and we'll see that it's been completed as well. So we haven't quite hooked it up fully yet. What we need to be able to do is, for each time that we have high demand, call that Azure function. And for that, we're using this for each writer or extending this for each writer. That's a part of Scala. That basically says, for each thing that happens, go ahead and write this thing out. And it comes with 3 different things: an open, a process, and a close function. Close, we don't have to worry about. We're not doing anything special there. For open, this is where we can basically set up any state that we need to. So we're just creating our restock transaction manager there. That's very easy. And then for each row as it comes in, we're getting the name, we're getting the actual number of purchases, we're getting the store name, and we're calling our Azure function here on line 18 that I've highlighted right there. And we're going ahead and filling our order then and ordering more items. So we can go ahead and actually run that, where we say here for the stream. Oh, I think I haven't run this up here. So go ahead and run that, and then we can run it here. And this is just saying, for each thing that's coming in where the actual number of purchases is greater than the expected maximum purchases, then call this reaction writer, and that will actually automatically call our Azure function and order new things for us. Okay, so we want to be able to persist that out to other systems and things like that. So we've already seen that we can connect to Cosmos DB. We're going to do that here in order to persist all of this to cold storage. So this is just setting up code for being able to take the items as they come into our Event Hub and just push them over to Cosmos DB, so that years later from now, we can go ahead and read this data, and our analytics team can look and see what purchases were over the past 5 years and things like that. This does that automatically for us. So none of this data is going to get lost. We're going to go ahead and stop the stream. All right. So if we go ahead and run this right here, we're going to read in our Cosmos DB data here, and we're just going to get just the order numbers, the names, and the store names here. So we can even look at our data inside of Cosmos DB, inside of our Azure Databricks instance here. So that's really great. All right. So if we want to export the data as JSON instead of being, in a string or a certain string format that we don't like, we can go ahead and use different migration tools like the Cosmos DB migration tool to be able to change our data from whatever form that's working really well for our real-time analytics, and change that over to a form that works really well for our long-term cold storage, so that we're never stuck with one type of data. We have always the tools at hand in order to do the job that we need to do. So if we go ahead and check the restock transactions table again, we'll be able to run this. And I don't know if we've had enough time for it to be able to reach high demand and place the order, but hopefully, yeah, we've seen here, we've gone ahead and completed a transaction based on the fact that we've had a high demand, we've placed that order through an Azure function into our Cosmos DB instance, and we've actually ordered new items for us because we've reached high demand. And I want to take a step back to kind of reiterate that again. This data was coming from IoT devices in real time, happening as we were sitting here in this room only a few minutes ago. It came through, we looked at it, we converted it from a string into a rich kind of data type. We looked at it, we aggregated it, we saw some interesting things about our data as they were coming in, and we could see right now screwdrivers were selling hot and these other items were not. And we knew that based on the data from the past 5 minutes. And we made decisions based on that data. So what we did is we looked at the data, we said, okay, if we have more screwdriver purchases in the past 2 minutes than, let's say, 17, we're going to go ahead and place an order automatically. We went ahead and did that. We placed the order, it went into our ordering system, and we saw that as it was persisted out into long-term cold storage. And that all happened inside of my browser window here very easily. So that's the demo right there. I want to make a shout out to the author of this demo, Lena Hall, who did a really awesome job on producing this here. I would definitely recommend, of course, you can come talk to me after the talk as well, but if you want to talk to her about the demo, she's available on Twitter at LenaDroid here. Definitely feel free to reach out. She would be more than happy to talk about the demo with you there as well. So let's take a step back and talk a little bit about the journey that we just went through. So we saw producing our data through IoT devices. We produced them in our stores from our cash registers. We pushed that up to an event hub where we collected our data, aggregated it together in one centralized point. We processed that data, and in our particular example, we processed that inside of Azure Databricks. So we pushed our data off there, and we could have pushed our data off to any number of sources, and we did that including cold storage inside of Cosmos DB. And we even reacted to the data as it came in and said, we have high demand for a certain item, let's go ahead and purchase that item. All right. So we've reached the end here. I'm going to leave this up real quick again. I recommend taking a picture or writing these down. These are the links that you saw before inside of our Learn Alerts to learn about what you saw today. And the really cool thing about these demos and things like that is that you can go ahead and try them out too for yourself. So everything you saw today, you can try out yourself as well, play around with it. And the great thing is you can just have fun with it. Just play with the data, make mistakes, see what you can come up with, and really have a fun time with it. Some more next steps. We've got some lesson plans and sessions, presentations for the tour today. You can get the code that you saw today inside of our GitHub, and you can even check out that awesome IoT Edge bogus data generator if you want to give that a try. Highly recommended. Again, talk to Lena Hall about Event Hubs and Databricks demo on Twitter. All right, and the slides are also available online as well. And the last thing I would ask from you is please make sure to evaluate this session. Let me know how I did so I can improve it for next time. And thank you very much.